Now starting. All attendees are in listen-only mode.
Hey guys, good morning, good afternoon, good evening, wherever you are in the world. My name is Mike Aubrey. I'm one of the participants in the Wildlife Conservation UAV Challenge, and welcome to our broadcast today. So with me, we have, of course, the insatiable Princess Aaliyah, and also with us a special guest today, John Glezellis. John, thank you for joining us. John has a wealth of flight experience, and he was actually a part of the Aurora project that originally first went to Kruger, and so we're very lucky to have him today. John, I'll let you give you your own introduction, but thank you so much for being here with us today.
Yeah,
And
thank you
Mike,
for inviting me to
yeah,
attend.
and Mike, thanks again for doing our introduction. I'm going to take a couple of minutes to just update the teams while John gets ready for his presentation. Hi, guys. I know we've been a little slow on getting the design review back to some of the teams. We're working on that. And the other thing we're going to do is we're actually going to change the dates of the critical design review and possibly eliminate one of the other dates for either flight readiness or critical design review and just combine it into one. Because I think one of the things we realized, we want the teams to focus on building their aircraft, not writing proposals and constantly being worried about, oh no, I have another submission due today. And sometimes that can be overwhelming. So what we want to do is we want to make sure that you guys are focused on the ability to work on your aircraft more so than just turning in different reports. So that's not what the challenge is about. The challenge is about finding a solution, and that's in your own way. And number two, we are really thrilled and excited to actually have General USD along with the other Parks delegation coming to visit. And they are meeting with our group tomorrow. And we will get feedback from them. And that's one of the reasons why we're just kind of holding back a little bit on the different dates that would be set. Once we meet with them, we'll have a better idea to see how to set up our new dates for the critical design review and the flight readiness, how we'll work with that. So that's the other reason why we had to wait. But I think having them here, meeting with our group from Aurora Flight Sciences, from Design Technologies, and Theta Tech Solutions, as well as Tom Snitch will be at this event as well. I think it will be a very powerful meeting for us to meet with the general and explain to them, last time we were in South Africa, we just went there on a fact-finding mission, but now we're the biggest challenge in the world with teams everywhere working to find a solution for Kruger National Park. So I'm excited about that. And I see that Scott, our director of South Africa, is on, but we'll have him do updates for South Africa at the end of the event. John is going to take about 25 to 30 minutes to do a
That's fine.
presentation on what he learned while we were on our fact-finding mission in South Africa, and then we'll have time for questions after that. Enjoy the show.
So to premise that before John jumps into it, I must say, as a participant, I have been so looking forward to this presentation. I mean, this is an opportunity for all of us. I'm sure you all realize that this is going to be the sort of primary source information that's going to allow us to make a solution that is custom built for Kruger and help actually solve the problem. So John, thank you so much for taking the time to be with us today.
Thank you for having me.
So with that, sir, yeah, we're excited. What do you got?
Sounds good. So I prepared a PowerPoint presentation. It basically just goes over SCATE, which is our small unmanned aircraft system, and the involvement we had in South Africa from our most recent trip and fact-finding mission. Before I begin, I'll just give you a brief background of myself and of the company that I work for, Aurora Flight Sciences. I'm a product development specialist at Aurora. I've been here for about almost 4 years now, and primarily involved with development for small unmanned aircraft systems, so like SCATE, which you'll see, which is a 2-pound airplane, as well as some of the other cool projects that we have going on. Regarding Aurora, we're a leader in development and manufacturing for unmanned systems, and we're actually coming up on our 25th anniversary. Our headquarters is in Manassas, Virginia. We have production facilities in Bridgeport, West Virginia, and Columbus, Mississippi, and our R&D facility is here in Cambridge, Massachusetts, which is where I'm based out of. And if you go on our website, which is www.aurora.aero, you'll see that we currently have 3 product offerings. One is Centaur, which is an optionally piloted vehicle. One is Orion, which is fairly large. Fly for 5 days, extended endurance, 1,000-pound payload. And third, on the opposite end of the spectrum, is Skate, which is our tactical UAS. That's what we'll cover in this presentation. So that's a little background on me here at the company and a small segment of what we've done. Everyone can see the slides fine?
So let's I just change. Yes.
Okay, awesome.
Okay.
Awesome. Any questions so far, or?
No questions yet.
Okay. So this covers the outline of the presentation, our agenda. So we'll look into a change in the future that's required. We'll look at current aerial vehicles in South Africa, critical SUAS elements, small unmanned aircraft systems, an overview of the Skate SUAS, our specific Skate demonstrations and fact-finding mission, and we'll conclude with our questions and answers segment.
Awesome.
So change in the future. Here's some numbers that we've seen. Rhino killings. So we saw that 13 rhinos were killed in 2007, and that number became 448 a few years later. In 2013, in Kruger alone, 573 rhinos were killed. And as we've learned, proper use of a small unmanned aircraft system, which will go forth in the presentation of SUAS, our Rangers will, without a doubt, have an impact on this number. So as one can see, rhino poaching is a difficult problem to overcome. The fact that the rhino horn is considered traditional medicine for a variety of ailments in Asia and is also used for ceremonial purposes in Yemen. There's a very high demand for this. And consequences of getting caught are limited, and which makes it appealing to the locals. And really need to implement an unmanned air vehicle shortly. Here you'll see the current air vehicles in South Africa. They're currently using a few much larger platforms. On the bottom, you can see there's a photo of Seeker 2, which the South African Air Force has both used Seeker 1 and Seeker 2, which are similarly sized vehicles. They're very large, 5.8-meter wingspan, 40-kilogram payload, can fly for 200 kilometers, which is great for long flights and extended endurance. But we need something that's small, tactical, that a Ranger can deploy. We know that Kruger National Park has used the Seeker Seabird, which is actually a manned aircraft. It's a reconnaissance aircraft, as well as the Seeker 2, which is unmanned, and that's what you can see in that photo there. Long endurance airplane has its benefits, but tactical UAS has many advantages. For example, basically extends the ability of the Ranger. It's something that they can carry anywhere that they are within the park. As you'll see with Skate, weighs only 2 pounds for just one aircraft, but actually weighs about 7.5 pounds for the entire system, which includes 2 airplanes and 1 GCS. So the future for unmanned aircraft systems. So upon speaking with Rangers and generals alike, it was clear that a successful SUAS would contain each of the following elements, and these were extremely important. The first thing that General Eustace actually mentioned was high-resolution optics. So they need something that provides stabilized electro-optical and infrared cameras. It's important to use an IR camera to see through the African thick, and we know that some areas, are lush and there's fields, but there's other areas that are really densely covered. For example, there's a lot of trees around, and poachers, like if they feel that they're being chased, they can easily hide. So an IR camera is needed to see through the trees and through the thick to see their exact location. We need something that's quiet at the operational altitude, and that's something where definitely electric type aircraft, that's powered with a lithium polymer battery, has its advantages. Something that doesn't have an internal combustion engine. Next, they needed a system that can handle their common environment, which is known as the African bush. We know temperatures are pretty high, densely covered areas, and there's a lot of rocks, thorn trees, etc. Interestingly, the thorns themselves in the trees were extremely large, probably between around 7 inches or so to 8 inches at max. And through some of our flights, skate actually landed in those areas. And the aircraft itself is durable and was perfectly fine. So we proved that platform can handle each of these 3 points. Regarding the high-resolution optics, earlier I said it must be stabilized. So that can occur digitally, which is what we've done with skate. Or of course, you can use a mechanical type gimbal, which a lot of other solutions are using. The disadvantage there is that there's more components that can break, where digital stabilization in a rugged airframe is very robust. So that's where it has its benefits. Let's take a look at integration into the current landscape. So we know that government-owned parks can legally fly UAVs without special exceptions. Regarding skate, and we thank Scott Williams for this and his involvement, by the time we were in South Africa, we had authorization and NOTAMs in place, NOTAMs being Notice to Airmen. So all the flying that we did while on our trip was approved. For UAVs, we know that there's interest with the costs of them. So, for example, UAV versus a manned aircraft, we don't have this cheaper operating costs. You don't need to have a manned pilot in the air vehicle. Cheaper to maintain. Regarding park security teams, we know that they're currently at a significant disadvantage, and having an aircraft like skate or something similar would significantly strengthen their presence and ability to combat poaching. From our time in South Africa, we learned that rangers, their methods are typically reactionary. They'll be in search for a poacher, looking for rhino locations, whatever they're doing on their day-to-day basis, their tasks. They may hear a gunshot, and when that's heard, they'll actually start running out to that location. At that point, most likely it's going to be too late. They'll find the rhino already deceased. So we really need to find a way to implement these types of air vehicles into this environment so we can change the current tactics. We'd like to find, of course, the poachers before that shot is fired. And that's where we have the ability to make a change, make a difference. I also just wanted to mention that I know typically the media portrays rangers as being equipped with guns and going after poachers in somewhat of a negative type manner. And being in South Africa firsthand, we learned that wasn't the case. Like the group that we were with, like at most, they'll have their water canteen for their outing for the day or for a few days at a time, some food, and at most a radio, even at times, just to call in to other rangers to get them into a specific coordinate point if that shot is heard to make a difference. So I just wanted to mention that as well. So I know it will take, some time for the CEA, which is the Civil Aviation Authority in South Africa, to integrate UASs into their environment, but that change is coming. It's a similar struggle that we face here in the U.S., but change is around the corner. So here we have a map of South Africa, and there's 4 circles, and this is where we started our fact-finding mission. We basically started at Kruger Park at the upper right-hand corner, then went to Pretoria, Port Elizabeth, and ended our trip in Cape Town. While in Kruger, we flew for the South African National Park officials, as well as the South African National Defense Force. While there, we also performed a flight near the border of Mozambique. Also, we flew for private security groups, mainly in Pretoria and Cape Town, and then we flew at a game lodge in Port Elizabeth. So it gives you a brief overview of, I believe it was the 2 weeks or so that we had spent in South Africa. So many flights were performed. This occurred during the month of November, and after the trip, it was clear that a need for situational awareness must exist. And in the interest of operators, their aircraft, their air vehicle must be easy to use. Can't stress this point enough. They must have quick launch recovery methods to get the aircraft airborne. And also we need to think about the environment that they're operating in. They might be on a mountainside. They might be in thickly covered trees where they have a small opening. It's ideal for an airplane to launch with limited space. Skate has a high power-to-weight ratio. We'll get into that shortly, which makes it ideal for these certain applications. We know that the airplane has to be quiet. So poachers were on the search. They're very keen to their environment, their surroundings, and they're keen on anything that is different about what is going on from their day-to-day activities. So if there's a sound that's different, they're cautious about it. The UAV has to be quiet, and it has to provide, of course, live video feed. Let's give you a little overview now of the skate system, which is what we've been mentioning. There's a photo here. It doesn't really do it justice. I have one model here that you can see, so you can see that the aircraft itself, in front of the camera, is pretty small. The wingspan is about 24 inches. The length of the aircraft is 19 inches. Overall weight is 2.2 pounds. The aircraft from the operator, which we'll call the home point, can fly a distance of anywhere between 3 and 5 kilometers, and it varies depending on which antenna is being used. So we offer a few different antenna selections. The airplane can fly for 60 minutes. Operational altitude listed as 400 feet above ground, and that's where the cameras themselves are focused best at. And of course, the airplane is inaudible at this altitude, which is key. The payload, our basic configuration, has 4 EO cameras, electro-optical cameras. I'll show you that here. You can see in the photo, video. The aircraft itself is modular, so that just means that everything clips into place, comes apart easily. No tools are actually needed to assemble the airplane. So here you can see the airplane is all assembled. You can disassemble it, unclipping the payload pod. This is the most useful part of the aircraft. In the interest of the operator, it has the cameras. We'll cover that in a second. You can see here there's also motor pods, and they're actually magnetized. They come off. So in the event of a landing or a crash instance, or if the airplane lands in a tree or anything that happens that's unplanned, the airplane essentially can't be damaged. We've done our damage testing with the aircraft, and it is extremely durable. On the back of the airplane, you can see there's vertical fin sets, the tail section. And these are friction fit. So again, no tools are needed for this airplane to put it together. You can actually go from a completely stored state to flying in a matter of minutes. So I'll talk a little bit about the payload pod. So this looks like the typical fuselage section on an aircraft. We call it the payload pod. It has 4 electro-optical cameras, which are all digitally stabilized. So there's a forward-facing camera, bottom-facing camera, and there's 2 side-facing cameras. We'll describe that when we get into mission specifics. We also have another payload pod that has an HD camera, and then lastly, an IR payload pod. So we use both the FLIR 320 and 640 cameras. Launch method on this airplane, it's 2 pounds. It's just a simple hand launch from the operator. Just holding the airplane at the wingtips. Just giving it a little launch at a 45-degree angle. This is ideal because no dedicated launch equipment is needed to get the aircraft airborne. And the aircraft also has many autonomous features as well as a few manual features. I'll describe that now. Autonomously, the takeoff and landing procedure are fully autonomous. Also, you can send the aircraft to waypoints, so for 4 different waypoints. And that can actually happen on a laptop or toughbook type computer. You can plan your mission out before you actually get airborne. Or, let's say there's a situation where we're not sure of our surroundings, need to go investigate a specific area, increase their situational awareness. What the operator can do is command the aircraft to take off. What will happen is it'll go through the takeoff procedure. We'll start circling the operator at about 60 meters or so. And then the operator can take the aircraft in what's called manual mode. or also steer the camera mode. Essentially, it's just like driving a car. You can steer the aircraft and the camera right and left. You can control altitude, but the airplane maintains altitude on its own. Makes it very easy to learn how to fly the airplane. You don't have to worry about any pitch or elevator commands. And this is useful because what you'll do is you'll use the nose camera to fly to a specific area of interest. Let's say that you see someone walking on the side of a road. What you'll do then is you'll switch to the bottom-facing camera until you're directly over that target area of interest. You can drop a waypoint in that spot, and then you can command the aircraft to loiter that point. And that's where the sideward-facing cameras are ideal. And that'll happen autonomously. The airplane, very rugged. It's made out of expanded polypropylene foam. So you can see here, it's a white-type foam, very durable, has a rubber-like texture. During the development stage of this airplane, we tried a few different composite methods and actually found that this type of material worked best. It's very rugged, can't really be fractured. If it tears, it can be repaired easily, and it keeps costs down. On the left, you can see there's an image that has a typical skate-based system with a soft backpack. So in that photo, you can see there's two airplanes, and there's the GCS unit. You can see there's the hand controller on the bottom right. Also on the right-hand side, you can see there's a cable set, and there's a battery pack right behind that cable set, and that's just to power the ground control station alone. The soft case can fit two airplanes and the GCS within it, and this is ideal for a ranger. They can simply strap this over their back, walk out to a location, and get the aircraft airborne in a matter of minutes. And again, here's the aircraft again in the GCS unit. A little more detail and clarity, just so you can see it. So there's the two airframes. I showed you one of them earlier. For the controller, looking at the numbers, so we'll start off. Number 1 is the air vehicle. There's 2 of them. Number 2 is a radio brick. This has our antenna mounted on it. This will typically go either on a tripod, on top of a vehicle, car, or also it can go on top of like a soldier's type rucksack. It just has to be elevated a few feet from the ground. So the radio brick, the controller, which is number 3, all plug into what we call the hub box. It's a central processing unit. And then we also have the 2590 battery source, which is a military-grade battery, which is number 5. That also plugs into the hub box, which is the central processing unit. So all those units plug into the hub box, and within minutes, the airplane can get airborne. The ideal thing is to have a rugged system, and you can see here, it is. You need something that can be thrown in the backpack and can get abused, and they do. I mean, the skate system has been deployed in Afghanistan. We've used it in South Africa on numerous events, and it's really held up well with hundreds of hours of flight time, even just on one specific aircraft. So how does skate fly? I don't know if you saw from the video, from the photos, there's no actual control surfaces on the aircraft. Everything is done through thrust vectoring and differential thrust. So what that means is roll, pitch, and yaw commands are commanded from the motor. So you can see here, if it's clear enough. So we have the motors. So it's a twin. This is one left and right side of the aircraft. They're actuated. So for the aircraft to climb, the throttle percentage will increase. Motors will pivot up. To roll, let's say we want to roll to the left motor will pivot down, and the right one will pivot up. What this does is there's no control surface on the aircraft, anything that can, external linkages that can break. Again, the motor pods themselves are magnetized, so they can be thrown on the airplane crashes, it lands, they pop right off, get the airplane airborne again, so they make sure everything is in working order, put the motor pods back in place, and get airborne. This was the key. We didn't want any type of actuators to break easily, and having those motors magnetized really helps out. Here you can see there's our typical mission. So this is like typically what they would use it for, like in Afghanistan. Again, the missions that are flown there, pretty similar to just a ranger looking for poetry. You're looking for an area of interest, an target, and just increasing your situational awareness. So here I'll just go quickly through numbers 1 through 5. Say your team on patrol receives contact from a known position, take immediate cover. Get the aircraft ready for flight. So disassemble it, take everything out of the case that's provided, get the aircraft assembled, the GCS assembled, do the pre-flight operation, and get it airborne. This can happen in 3 minutes. So it really decreases that amount of time compared to some other types of platforms that exist. On the hand controller, you'll command the auto takeoff feature. So the aircraft will climb to altitude and start loitering the operator. You can then command the aircraft to perform autonomous loiter, and you'll just be viewing the video from the aircraft. If you see something of interest, you can drop a waypoint through the hand controller over that area, and then you can command the aircraft to loiter that specific area. So whenever you're loitering, the airplane, of course, loiters in the left-hand circle, and the cameras themselves on the left-hand side of the fuselage, the payload pod. You can always maintain eyes on that position. And everything is geo-referenced, so you know where exactly the aircraft is in relation to where the operator is, and you'll know like where that target or area of interest is. And just remember, the airplane can fly anywhere between 3.5 kilometers to 5 kilometers maximum away from the operator, and that is the range of the system. By default, we do have what's called a safe boundary or return to home circle. If the aircraft flies beyond that imaginary circle, the aircraft will return home autonomously on its own. So the operator can just really focus on the imagery that they need and just focus only on the video, because in the end, that's what the aircraft is there for and there to provide them with. So here's some benefits specifically for the SCAPE platform. So we know that it can immediately disrupt poaching activities due to the following. It's easy to operate, and I'll actually give an example shortly. It has an electric propulsion system, so it's extremely quiet, yet it's reliable. So no matter what altitude the aircraft is flying at, no matter what elevation you begin your mission at, it's not like an internal combustion engine where there's different carburetor type adjustments that need to take place to get the engine in a fully reliable state. Simply plug and play ready. Plug in the battery pack, the lithium polymer battery pack, and the aircraft is ready to go. As you saw earlier, it's man-portable, extremely lightweight. Again, the system weight is only 7.5 pounds, and really worked on keeping the aircraft light, because in the end, this is the weight that the ranger, soldier, whoever is going to be operating the system has to carry on a daily basis, and you need that to be both light and rugged, which we achieved with the EPP airframe, EPP being expanded polypropylene foam. Quick deployment time. Again, within 3 minutes, the airplane can go from a packed state to flying. For optics, we know that the IR camera can easily see through the African thick and heavily forested areas, and that is the most useful camera to increase situational awareness. High resolution, of course, is important, and in the case of SCAPE, having digitally stabilized EO, IR, HD video, and everything is, again, is geo-referenced. So you know the exact coordinate of the aircraft, as well as any specific coordinate either on your map or any area of interest that you find. Here you'll see there's a picture. It was actually a ranger getting some stick time on SCAPE while we're in South Africa. And it was pretty neat because within essentially only a 15-minute, 20-minute ground school crash course, he was actually operating the system on his own. And this is due to the fact that everything is commanded through the joystick. the controller rather, and is autonomous. So this just makes anyone that has like no flying background whatsoever able to fly this type of a vehicle and focus on the video imagery. During one of our flights, we had an operation near Mozambique. I'll quickly describe this. So there's a star on the top section of the map, and that was our launch and recovery point. You'll see the yellow arrows, the flight path of the vehicle at different times, and the red circle is a loiter point. So we basically flew out almost 1 kilometer from where we began the mission at. So what we did is we performed the auto launch with the airplane circle us. We looked at our map, looked at the live video that was streaming from the hand controller, and we wanted to fly out to this riverway. So apparently, and you could see it while we were there, there's people that are crossing the border from Mozambique into South Africa on canoes. And the whole point during this mission was to provide live video for the South African National Defense Forces, so they could see people on their canoes and whatnot before they crossed the border, just so members of the forces were aware of that and they could strategically plan their next action. So what we did is perform the auto takeoff, let the airplane loiter. We manually flew the aircraft. So again, manually just means that the aircraft maintained altitude on its own. All the operator worried about was steering right and left to get to an area of interest, which in this case was the riverway. As soon as we were over the river, we dropped a waypoint in that point, and we loitered a few rotations, and then essentially returned the aircraft home. And again, that was actually done autonomously as well. There's a command on the joystick where there's a return to home function. So the neat thing with Skate is everything is done through the hand controller, and everything is basically a 2-click operation to perform a certain function, whether it's getting the aircraft to take off, to land, to loiter, changing cameras. Everything is just 2 clicks on the controller. It decreases time to engage that function and makes it extremely easy to use, which is important. Interestingly, while we were flying this mission, when we arrived at the location, it was pretty calm. In other words, winds were relatively low. But right after we concluded the mission, winds picked up. And it's interesting to see how quickly weather can change in this area of South Africa. Type winds, which we don't deal with, more so like in the Cambridge area, Massachusetts, where this office is based out of. But something to keep in mind is that winds can change, storms take place, and here it happens pretty quickly, and you must have an aircraft that can handle that and that can return home in those types of conditions. Skate is relatively small. Again, it weighs 2.2 pounds, but we can fly in winds up to 20 knots. So it really can handle winds very well, considering it's such a small platform. So that's just something to think about. You need to make sure wind performance is very good in your vehicle. So let's take a look at how easy the aircraft is to use. In this photo, so while we're at Kruger, we met up with Section Ranger Lundella, Rodney Lundella, and we basically gave him a crash course on the system, only about 20 minutes of training, and that was basically just going through the operation of the controller, how to assemble GCS, so both the hand controller, the hub box, the radio brick. You can see the radio brick is actually mounted on top of the Jeep here in the photo. How to get everything assembled, the basic features in the controller, so how to activate the auto takeoff block. And on our controller, everything has icons. So there's a photo, for example, is an image of the aircraft climbing to signify takeoff, descending to signify landing. Everything is very simple to use. And this made it possible to train him in a matter of 20 minutes to perform a mission on his own. So he told us on the way up to this location that he, on a daily basis, essentially looks at 2 types of entry points that poachers are known to come through. One was a bridge, and the other were a few different riverways. And typically on a daily basis, I mean, he'll spend up to 5 hours on foot, using the vehicle, the car, to observe and to look over these areas. With Skate, in a matter of 2 flights, 20 minutes later, he achieved this. So it really shows the usefulness in an unmanned aerial solution and the benefits that it can provide. So for example, it saved him 5 hours out of his day in a 20-minute flight. So now he can strategically plan where his next move is going to go and be efficient, which is the key, especially when time is limited, as we've seen. So we know the need is now. I believe Scott is in on this and is attending. And there's a quote from him. He says, "To date, no other product has proven the need for a low-cost tactical UAV as an extension of the Ranger in the field for wildlife security. The U.S. team to perform in the African bush is a testament to their product. This airplane is very reliable, and that is the key. Rangers, operators, they need a system that they can trust, that whether it's stored on a shelf for a year or whether it's abused on a daily basis, whether it's going through the African bush, whatever happens, that when they put the aircraft together, everything's going to function as needed. It needs to be able to provide stabilized video, because that is what it's there for." There's also another quote on the bottom from Lee Lachliet. He claims that a system like this would have been used, it was in the last 16 incidents, this for the poachings, would have made a difference. So we can see the need is urgent, and benefits that small unmanned aircraft system are on this. So final thoughts before we actually get into our questions and answers segment. We know that we need UAV implemented in South Africa as well as other locations. We've seen that the struggle, resources, and how Skate can specifically allow rangers to survey a greater amount of area, like you saw earlier, provide IR optics to detect hotspots, provide GPS coordinates of defined hotspots, survey areas where dangers are high and for safety, and allow rangers to strategically execute certain missions. The next bullet goes into the fact that park security missions are interestingly very similar to those that are performed in Afghanistan. The mission itself is simple. You need to increase situational awareness, and this has to happen through a system that has many autonomous features and that is very easy to use. Now the questions and answers segment.
Yeah, well, we have a couple.
Sounds good.
Yeah, on the specs of stuff, so the most immediate question we had pertaining to the reconnaissance stuff, Sai had a question. Are there any issues related to line of sight for video and telemetry like hills and valleys?
So there are. Typically, like what you saw for the Mozambique flight, we situated ourselves on top of a hill and made sure that we always had line of sight with the aircraft, so we never flew behind a hill or anything of that nature. The aircraft Skate does have a return-to-home feature autonomously, so if there is any link loss, the aircraft will return home. And the flight modes that the aircraft is in are all indicated on the GCS. So basically, the operator himself or herself can just be looking at the video feed, not really have to worry about link status. The video supplied with Skate streaming live, and there is a telemetry link that is on the hand controller. But again, they need to focus just on the video, and if there's any loss in telemetry or link with the aircraft, it will return home. But long story short, one must always keep like the radio brick itself elevated and fly at a higher elevation.
Okay. What radio frequencies are you using, and are they regulated by South Africa? Do you have to stay within a certain range?
So we're using 2.4 gigahertz.
That was 3.4?
2.4.
2.4. Okay, yep.
2.4, but it's a digital data link. Essentially, that means that both video and telemetry with the aircraft are streaming through that. So it's not like a lot of hobby type products, you'll see they'll be like either on like the 900 megahertz band or 5.8 gigahertz. This is just on 2.4 for both the aircraft telemetry, control, and video.
Okay. Next question comes from Michael Robbins. What is the black-looking spars in the skate wings? Are they just structural?
Oh, okay. So those are, you can see them here. So those are they're carbon stiffeners. So the skate wing can actually fold in half span-wise. I can show you the photo again, but that's to be able to make the airplane fold up and fit within a small space, and like the soft case that we had in the image. So those simply just support the wing itself. So that's all that was for.
Okay. Next question: how many TV lines are your cameras?
Can't really disclose it. I apologize.
Got it. Sure. Makes sense.
So I apologize. There'll be some questions I can answer and others that I can't, but I'll do my best to address that.
So Sai has a follow-up question to the 2.4 gigahertz processing. Are there delicensed frequencies that are allowed to be used in South Africa? I mean, is this something that you guys just picked, or is this something that was mandated?
This is something that is mandated, and I believe LB is on the line. Maybe we can talk with him afterwards about that, because he was essentially our organizer for some of these missions that we performed. But like mentioned earlier, we did have approval to fly the skate system at each of those locations. Okay. So I know, just like the issues that the FAA is facing right now, I mean, there is a deadline in the U.S. for 2015 to integrate civil use of UAVs, and South Africa is doing the same thing. So it's a pretty big gray area, and no permission is granted on a case-by-case basis. But for skates flights, everything was approved beforehand.
Okay. I have a question for you about the nature of the image recognition you're gathering. So you mentioned that as kind of two areas you're looking for things. You're looking for humans that are passing over bridges and canoes. Is it as simple as identifying humans and canoes in those areas, or are you looking for more specific things as well to help narrow down and filter results?
So in these cases, we're just looking for like a simple object, simple human, or some type of movement. Obviously, you can see that easily with an infrared camera. A little more difficult to do with the EO, the daylight electrical optical cameras. That's only as good as what the human eye is and what you can see from the hand controller. But
so when you say that you're when you say that you're looking for movement, are you looking for things like just the topology has changed? I mean, is that like potentially identifying like maybe where something is camouflaged?
I'm looking for movement just simply as an animal or a human.
Animal or human? Okay.
Exactly.
Okay. Okay. You described a fair amount about what was working with the systems that you mentioned, things like the ease of setup, having modular systems, disassembly time, being highly durable. Can you describe some of the things that you didn't expect that would be challenges in Kruger? Like what didn't work?
Difficult to say. I mean, everything with the system was designed. It's a vetted solution. Can you be a little more specific? As far as like surprises, maybe to the environment.
Yeah. What surprised you? That was environment based, and then just in general, what the Rangers asked you for that you were, oh, I never thought of that.
Yeah. So as far as the environment, the only thing that really surprised me were some of the thorn bushes that were present there.
Okay.
So not like something typical like you see like in the U.S., but I mean these had thorns that were 8 inches long, so it could easily puncture or pierce through an airframe. And by the way, say again?
They were 8 inches long.
Exactly. So I've never seen anything quite like that. And so I mean, that's one of the possible threats to an aircraft. Sure, it's something to think about.
Okay.
Can I actually talk about my experience with skate? Can you hear me?
Yeah, definitely.
Okay. I actually had an opportunity to go out last week on Monday last week and fly skate here. It's weird that, yes, I went on this fact-finding mission but didn't have an opportunity to fly skate. So I wanted to make sure I was able to do that and understand it, because one of the things we're creating is our boots on the ground, wings in the air training program for the Rangers in South Africa. So I figured it would make sense for me to go out, fly skate, and understand from a user's perspective what are some of the things that the trainer has to look at when they're working with these people that don't have experience. And yes, that was my first time flying skate, but also flying a drone. So it was very easy. Within, I think, like a couple of minutes, we were set up. I got a chance to plug everything in into the right locations. And then Ellis Langford actually gave me the training course. I appreciate that. And we were flying, and it was really easy. As soon as skate took off, I was like, wow, this is like flying a kite. And it literally was, because it's almost like, you just throw skate up in the air and it's off on its own. And now all I had to do was figure out where I wanted it to loiter, and or where it should go or anything. So I think part of what we learned when we went to South Africa was rangers are not geared to understand and stare at a screen. And one of the reasons why we wanted to have a competition is because after 15 minutes of staring at your screen, that doesn't really give you anything useful unless you're on a counter poaching mission and you're particularly looking for something. You're going to stay engaged for a longer period of time. But if you're just streaming a video, after about 15 minutes of it, most people are going to lose interest, and you might turn your head, or maybe a bathroom break or something, and now you're left with nobody monitoring the screen anymore. And that could be critical in terms of being able to save a rhino or any of the other animals that could possibly get poached during that period of time. So that's why our challenge focuses on the embedded systems, the ability to actually process that data and give the rangers and the operations team an actionable information. So basically, where are the rangers? What's their proximity to the rhinos? How many of them are there? And what types of weapons are they carrying? So we want to be able to provide this information to the rangers in terms of what they need to do, because that's what they've been trained. And you can't go into a field and retrain people to redo their job, because now it's the difficulty of learning a new system. It's the difficulty of integrating that new system into what you've been doing for the last 20, 24 years, for example, with Rodney. All of a sudden, he can't just go in and change the way he's going to do his patrolling or his counter poaching. What they know is, okay, we've got to call their poachers in that area of southeast somewhere. We've got to go out and find them. But now, if the UAV can provide the exact location of where the poachers are, it makes it easier for the rangers to do their job, which is go out and find these people. So we want to make sure that the teams understand the importance of the challenges on the embedded systems, the ability of us to be able to process the data on board and deliver an actionable message or an alert to the operations team that would be in Kruger. All right, John, sorry, I didn't want to take over. LB might have something to say. Do we have any other questions? Mike?
Fresh questions. There are some pertaining to clarification around the requirements that you
Okay.
mentioned at the beginning. So if you wanted to nail down, what has changed, that would be, there are a couple
Oh,
questions
yes.
there.
Okay, so one of the
Yeah.
things that has changed, I know all of you are waiting for us to release the critical design report criteria. Unfortunately, well, I guess there's good news and bad news. The good news is you won't have to do that on April 30th. And there is really no bad news, because you just have less work to do in terms of paperwork. So what we're going to be doing is combining two of the other deadlines into one deadline. And that would end up being June 30th, but we're not really sure how much information we would want on that. So we're meeting with the general tomorrow. We'll have a better understanding of what's going on Kruger right now. And then that would help us figure out the next stage of what we would want the teams to submit to us, because maybe some of the requirements might change from our meeting with the general as well. So that's the reason why we're holding up on providing you the new deadlines as well as the requirements of what that deadline would need. So that deadline would be June 30th, so it gives you a couple of months. But what we want you to focus on is building your aircraft. That's the most important part, is building your aircraft. And keep in mind, one of the things we want to make sure all the teams are able to do is participate at the finals. So for that, we are setting up a makerspace in Amakala, Port Elizabeth, where if anything during your travel and transportation, you have broken wings or electrical problems, you'll have a facility where you can actually fix your UAVs and or electrical issues. And we have a great webinar on what is a makerspace by ADX Portland. So if you guys want, you can go ahead and watch that. That was from our last one on our website to learn more about makerspaces. But that's an important factor in what we're doing, is the ability of these people around the world who are able to make things together and find solutions such as what we're doing right now. I hope that answers the question, Mike.
Okay, so to summarize that, so the April 30th deadline is being relaxed and merged into June 30th, and there will be changes coming in the near future on the basis of the meeting you're having tomorrow with Kruger.
That's absolutely right. Thank you. You're great. This is the reason why you're our organizer.
Oh, you're too kind. Question about skate. You mentioned that they've really embraced the skate. How many skates are in operation right now?
So skates
Can you
can't
even
show specific numbers.
Sure.
Again, they have been used in Afghanistan, as well as for some types of educational type purposes. In the past, we have used systems with Vanderbilt University, for example. But for exact numbers, we can't get into too many specifics.
Okay.
But the demand is there, especially in these types of platforms of this size.
In your opinion on the skate, one of the things you mentioned is that it's very compact and easy to deploy. But on the second thing, I noticed that because it's so compact, you take a bit of a hit in terms of its duration that you can be in the air. You mentioned it's only got a 5-kilometer distance before it has to be recharged. What do you think the sweet spot is between kind of like longevity versus deployability? I guess if that's the right word.
So interestingly, as far as the 5-kilometer point, that's only the distance that the airplane can fly away from the operator. That's related to video length. So if you want streaming live video with no interruption, you're guaranteed that distance. So that isn't linked with the duration. So you saw earlier, like in the Mozambique flights that we did, we dropped a waypoint over the river, loiter that specific point, and you can loiter that point for up to an hour or so. It's one of those things where the entire duration, so from takeoff to landing, it's about 60 minutes. And surprisingly, for a vehicle of this size, it's actually one of the longest types of durations, exactly. So if you compare with a similar platform, typically the rotor-type aircraft, you're getting anywhere between 30 and 45 minutes tops. And I know Raven, I believe, is around 60 minutes, which is quite a bit larger than Skate, and quite a bit heavier.
Okay. That's helpful. Because we are actually, for our competition, we're judged on duration. Like how long we can be in the air, we're actually rewarded for the longer it stays in the air. So it's interesting to... Yeah,
so there's a balance between overall weight and size that has to be found.
Okay. Let's see here. I don't see any new questions, guys. I know I'm being selfish here and I'm asking my questions, so I guess I don't really apologize too much for that. Yeah, so but Michael threw out I guess I'll echo Michael Robbins' comment here that your weight to equipment payload is really impressive. I mean, that's a pretty tiny bird there that you're able to cram a lot of equipment in there.
Exactly.
It's impressive.
Scott, LB, can you hear me? Because I've unmuted you, and for some reason I can't send you a message on this. I do have a quick poll that I wanted to ask the teams about. Have you guys seen our fact-finding mission video? Because Skate's in that, and we're demonstrating how it was used in Kruger National Park. So I'm going to just ask this question for the teams, and if you haven't seen it, I'm going to send you a link for it. There it is. Can you see the poll, guys?
Kits has seen it. I've seen it.
Okay, good. Launch.
So
Okay, there we go.
Look at you operating the polls there. Nice
I
job.
know, right? Ha, I'm getting techie.
Yeah.
Okay, so it seems like 50% have seen it, and 50, oh, okay, it keeps changing, but let's say
Yeah, I
50%
was gonna
have.
say, yeah, let them chime in, and then when you close it, we'll be able to see the results.
All right, okay.
That's cool.
Yeah, it's kind of interesting. We might end up doing another one integrating the videos from Skate as well, but that's going to take a little bit longer. We haven't been able to get around. I mean, just the challenge taking off so fast, it's incredible, but at the same time, uh, it's a lot of work, guys.
I
LB,
don't think you get much resistance from us on this end. We're doing it.
I know, and I'm so glad that you guys are doing the hard work, which is actually building the aircraft, and then we have to prepare for everything else. And we want to make sure that we get the teams the appropriate tools that they need. Now, it seems like we have people that are looking at the poll but haven't answered the question. So, if you haven't answered the question, can you guys answer the question real quick? And if you don't, I'm going to close the poll in like 2 seconds. Yes, right after I'm done talking. All right, okay, so 57% said they have not seen the video. So I think what I'll do is I'll send a link for the video, and that way it'll give you a better understanding of not just Skate, but the terrain and what we were dealing with in Kruger National Park. This is your time to find out more about what kind of challenges you're going to be facing. So I would recommend asking your questions. John would be able to answer those for you, but let me type this in.
John, I have a question around reporting. Actually, Priscilla, you might actually be able to offer some insight on this too. As we're gathering large amounts of information over an hour, you mentioned that the attention span of just someone who's wandering it will naturally waver. Is there anything in the way of an output or report that maybe the Rangers have suggested would be best or most desirable for them?
Well, I
How
think
can we
part of
help? Yeah, how can
part
we help synthesize the information so it's most useful?
Well, I think I'm meeting with the general tomorrow. Well, we can definitely ask that question from him. What is it that they currently use in terms of communicating with the Rangers to say, okay, we've got danger at this particular location. We need to send out a group. And I think what we want to do is we would want to provide them with the same type of information that they're already accustomed to, because coming up with new codes and new ways of processing that information for the Rangers is another challenge. We want to be able to help facilitate and enable them to do a better job with what they're already doing than add an additional requirement for them. So what we are hoping to
Okay.
do is just integrate their current command codes and just use those to relay the danger in the situation at hand.
Okay. John, do you have anything to add to that?
No, that was perfect.
Okay.
I do want to stress, if anyone wants to reach out to me, and I can provide a work email address. I don't know if Leah wants to post it later on, but it is first initial last name, so J Glezellis at aurora.aero, AERO. So just in case anything isn't quite asked or this presentation, or aphorism at any time, feel free to reach out.
Okay. Well, that sounds good. And I don't know what's going on with LB. He's not.
Scott was saying that he's having some trouble with his audio. He
Oh,
wanted to
okay.
throw out there that Skate as a tactical UAS system has been exceptionally reliable. In this case, for our competition, we don't have to just limit ourselves to just tactical UAS systems. There are other types of systems too. And actually, I was just writing him back to clarify what systems are also highly desirable. But yeah, we don't have to necessarily replicate the little short in the field version. There are other types of UAVs that would be useful. I'm paraphrasing Scott, but
Okay.
Fix
Thanks.
your microphone and you can talk.
I know, yeah. And for some reason, I can't see his question. Oh, here it is. Finally, I can finally communicate with him. Okay, I think there's one more question, and then we're gonna have to call it a day.
Absolutely. Sounds good. Final question. I guess Marcel, you have two, so we'll give you one of them. Uh, does the skate rely on the operator to recognize threats, or are there internal systems that do that?
So at this moment, it does rely completely on the operator.
Okay. All right. I guess we'll bring this bird to a close, or we'll land
Yeah,
it.
I'm actually on my way to meet with the designer of the Killer Bee, Mark Page, so I'm thrilled and looking forward to that meeting. And he has promised that he will do a blended wing webinar for us because I know we have some teams that would be interested in that, and he is the master of the blended wing. So if you guys get a chance, check out the Killer Bee. If you type it in, you'll see it, and he was the designer. So we're lucky to have him as part of our team and meeting with him so I could learn more about the blended wings as well. All right, well, thank you everyone for participating. Unfortunately, LB is not able to give us any updates from South Africa today, but we're hoping for our next webinar, which is on solar cells in UAV, and I think that was part of Marcel's question is solar, and that's our webinar next week on solar cells and UAVs and the potential of using it in Kruger National Park because that could be a very useful tool for Kruger. So that is our next week's webinar, same time, 11 a.m. Eastern time, Eastern Standard Time. I don't want to mess everybody up. It's Washington D.C. So make sure you know what time it is on your side of the world, because there have been some
Oh man.
emails that were sent. Sorry for the miscommunication in what time these webinars were, but we'll make sure that we stay consistent with the time of our webinars so everybody knows Thursdays 11 a.m. Eastern Pacific time for an hour would be our webinars. Mike, and you're ready for close.
Yeah. John, thank you so much for taking the time to present to us. That was exceptionally valuable. And so on behalf of all the teams, thank you for your time. Uh,
Thank you.
with
Thank you
that,
for allowing me.
guys, we'll see everyone next time. Thanks so much for showing up and happy flying.
All right, have a good one.
Take care, guys.
All right,
Take
Bye.
care.
cheers.